Let's face it, biological aging used to be a one-way trip on a rickety roller coaster where you just white-knuckled it until your knees gave out and your AARP card arrived. But thanks to the marvels of epigenetic clocks like GrimAge, PhenoAge, and the turbocharged Dunedin Pace, scientists are now treating aging more like a speedometer than a countdown timer. And this shift is not just academic. It's opening the door to a new era of nutritional biohacks, personalized medicine, and the deeply satisfying possibility that your cells might actually be younger than your driver's license says. Who needs Botox when you have methylation markers? Epigenetic clocks work by analyzing patterns of DNA methylation, basically little chemical tags that turn genes on or off without changing the genes themselves. It's like your genome is a symphony, and methylation is the conductor deciding which instruments play and which sit this one out. These clocks use statistical algorithms to interpret those patterns and estimate your biological age, which might be older or younger than your chronological age, depending on how many salad greens and squat reps you've managed in the last decade. Suddenly, that green smoothie you begrudgingly chug every morning is a tool of time travel. Who knew? GrimAge, with its slightly ominous name, was designed to predict time to death and health span outcomes by incorporating methylation-based estimators of plasma proteins and smoking history. It's the sort of tool that sounds like it belongs in a sci-fi dystopia, but instead might help your doctor figure out whether you're aging like fine wine or like unrefrigerated yogurt. PhenoAge is a little more wellness-friendly, linking methylation data to phenotypic measures like immune function and inflammation. Then there's Dunedin Pace, the millennial of the bunch, new, faster, and flashier, measuring the rate of aging rather than the age itself. Think of it as the difference between checking your watch and clocking your treadmill speed. Both are useful, but one tells you if you're sprinting toward a hip replacement or jogging slowly into your centennial birthday bash. These tools aren't just for lab rats and tweed-jacketed professors either. Increasingly, they're being used in clinical trials and longevity studies to measure whether certain lifestyle interventions, like caloric restriction, plant-based diets, or intermittent fasting, actually make a dent in aging biology. In other words, it's no longer enough to say kale is good for you. Now we want to know, does kale slow your Dunedin pace? And if it does, can we get it in gummy form? This opens up a buffet of deliciously nerdy research opportunities. How do different diets affect methylation patterns over time? Can stress reduction practices like mindfulness or forest bathing literally slow your epigenetic clock? Are there regional differences? Do people in Okinawa or Sardinia have a grim age that's stuck in the 90s, while the rest of us are careening toward 2040? Could personalized supplement regimens based on your methylation profile become the multivitamin of the future? But perhaps the most exciting angle is preventive medicine. Epigenetic clocks are being explored as early warning systems for diseases that usually creep up silently, like cardiovascular decline, cancer risk, or neurodegenerative disorders. If your PhenoAge suddenly spikes 5 years ahead of your chronological age, maybe it's time to revisit those skip checkups or start tracking your blood pressure with more interest than you track your screen time. This turns aging from a mystery into a manageable variable, something you can tweak, optimize, or at least curse with greater scientific precision. For science communicators, the opportunities are endless. There's room to unpack the ethical questions. How do we responsibly use age prediction in insurance or hiring? The socioeconomic angles. Will access to age-slowing interventions be equitable? And, of course, the cultural implications. What happens to our concept of old age when some 70-year-olds have the biology of 45-year-olds and the wardrobe to match? In the meantime, you might consider ordering a DNA methylation test just for fun. Who knows? Your cells might be throwing a youth party you weren't even invited to. Or they might be crying out for antioxidants and a brisk walk. Either way, we've officially entered the era where your age is less about candles on a cake and more about chemical whisperings on your genome. Aging may be inevitable, but how fast you go down the slide is suddenly up for negotiation, and epigenetic clocks are holding the stopwatch.